Thank you very much, Wes. Yep, so hello, thanks for coming to this talk on automated NMOS controller testing. So how it will work is I'll start by giving a bit of background, and then later on, Jonathan will give a couple of demonstrations to walk through how it all works. So the objective of what we're doing is really to achieve better interoperability, and good interoperability requires two things: common standards and specifications that everyone follows correctly, and testing to ensure compliance, that is, making sure everyone is following the specifications correctly. So in the world of professional media, we have the SMPTE ST2110 suite of standards for the data plane. So these allow us to use common formats for streaming video, audio, and metadata essences between media devices over the network. And for the control plane, we have the AMWA NMOS suite of specifications. So in particular, we have ISO 4 for discovering and registering new media devices as they are connected to the network, and ISO 5 for managing the connections between them, so they can send and receive the ST2110 media essences. So those NMOS specifications describe how to make API calls using HTTP-based operations, such as post, patch, get, and delete with JSON payloads. And it's important that the syntax of these exactly matches the specifications. Luckily, we have a good history in terms of testing these standards and specifications. So since the early days of ST2110, there have been a number of JTNM Dirty Hands workshops, and these have been held at physical locations and allow vendors to turn up and ensure their devices are able to send and receive streams from other vendors' devices. And the more recent JTNM workshops have also included some NMOS testing, but this has typically mainly been done at a series of AMWA workshops, where often, while the specifications are still being developed even, vendors could turn up and check the specifications were fit for purpose and that everyone's implementations would interoperate. There's also been some really useful software-based test tools made available to help everyone self-test their devices. In particular, the EBU have released the Live IP Software Toolkit, or LIST for short, to help users validate their ST2110 streams. And at AMWA, we've created the NMOS Testing Tool, allowing users to test the NMOS APIs are being used correctly. And over the last 2 years, the JTNM Tested initiative has also been introduced. So this allows vendors to have their devices officially tested by a testing team for both ST2110 and NMOS compliance. And they then receive a badge that can be used to advertise this. And 3 of these events have now taken place. The first was a physical event just before NAB 2019, and that tested 2110 compliance only. The second was another physical event, again, just before a major trade show, this time IBC 2019, and that added testing for NMOS and some other requirements set out in the JTNM TR 1001-1 document. And the third and most recent event was carried out remotely in March 2020 due to the start of COVID, and that mainly involved vendors self-testing their equipment using a prescribed method. And these events have really helped to improve interoperability, all these different events and initiatives. And for the NMOS tests that JTNM tested, it should be noted that these made good use of the NMOS testing tool. So more on that tool now. It's now a mature tool that allows vendors, users, and system integrators to test their NMOS registries and their nodes, that is the end media devices that we're connecting to the network. It now covers all the published AMWA NMOS specifications, from ISO 4 for discovery and registration to IS 10 for authorization, and also covers all the associated BCP best practice specifications too. And it's available for free. You can download it from AMWA TV's GitHub website at this link and use it to get up and running on your own network and very easily carry out your own tests for NMOS compliance. And as I mentioned, it's been used extensively at the recent JTNM tested events to perform the NMOS tests. in particular for nodes and registries at the August 2019 and the self-testing done in March 2020. However, up to now, there's been no automatic way to test NMOS controllers. So at the most recent JTNM test event in March 2020, this was instead done manually. So by an NMOS controller, in NMOS speak, we call them NMOS clients, but we're talking about the broadcast controller, basically. And at that recent JTNM tested event, vendors were required to connect their controller to a VPN and perform a sequence of actions that were verified manually by the testing team. And the aim was to test things such as, can the controller correctly discover all the devices on the network by querying the registry using ISO 4 and update its UI when these change? And also, can the controller successfully make connections between devices and correctly identify the connection state of any existing connections? So the first set of tests were mainly ISO 4, the second set mainly ISO 5. So this remote controller testing performed during JTNM tested worked something like this. The vendor ran up their NMOS controller on their own network and connected to the test network over VPN. And on the test network, which was run by CBC Radio Canada, there was a real NMOS registry and some real NMOS nodes. And the test team in Canada then instructed the vendor over a Zoom call to perform various operations using their controller. And then the test team verified that these were all done correctly. A separate call had to be set up for each vendor. And as you can imagine, the process was pretty demanding on resources and time for everyone involved. So the idea of the NMOS client testing activity in AMWA was to automate this process. So we aim to create semi-automated and fully automated testing functionality building on the existing NMOS testing tool and covering the same scope as the JTNM tested controller tests. And our approach was to set up an official AMWA activity for this. This was led by Sony and approved through the official process by the NMOS steering committee and then by the AMWA board. And as for all AMWA activities, we set out a clear scope and a clear set of deliverables, as well as defining a clear time frame for the activity, which was from May to September this year. So you'll note that that's just recently finished. And we had good participation from a number of end users and from other vendors as well. And the way we approached the work was that Sony created the semi-automated test framework, which builds on the existing NMOS testing tool. And we also created the test suite covering the JTNM tested tests, while other participants regularly tested the framework using their own controllers and provided regular, really valuable feedback on what was and wasn't working during weekly calls. So going back to our manual controller testing diagram, our aim was to remove the human test and verification team and replace them with the NMOS testing tool. So instead of the test team telling the vendor what to do, they receive instructions from the testing tool via an NMOS controller testing facade. So the testing tool uses a Q&A protocol to send questions to the facade that are then presented to the operator. The testing tool is able to set up a mock registry and several mock nodes, and then ask the performer to perform a sequence of operations using their NMOS controller under test and answer some questions on the results by the facade. The testing tool can then verify that the answers are correct, as well as verifying that the mock registry and nodes have received the correct API calls. And at the end, the testing tool then presents the user, the operator, with their test results. So the best way to explain this is with a demonstration. So over to Jonathan now, who'll show the controller testing in action using Sony's broadcast controller IP Live System Manager. So
Thanks, Rob.
Sharing.
Okay, I will start sharing, coming live from my own personal beer tent. Let's just So this is actually a pre-canned kind of run through of the controller testing, and I'll just kind of commentate on it as we go through. So what I'm doing is I'm showing the semi-automated testing of an NMOS controller using the NMOS testing tool, just as Rob's described. So the first thing we do is we launch the NMOS testing tool. So that's a Python application. We also then launch the testing facade. So this is where the test user will be given instructions which they need to follow in order to test their NMOS controller. So if we open a browser, we can browse to the NMOS testing tool. I'm running that on port 5000, and in a separate tab, I can browse to the testing facade, which is running on port 5001. So today, I'm testing Sony's IP Live System Manager as the NMOS controller under test. So the next thing I need to do on the NMOS testing tool is select the NMOS controller tests and configure it with the IP address and port of the testing facade. I then can select run all tests and hit run, and that gets everything underway. So if I now look at the testing facade, the first thing I see are the pre-test message. So this message gives some context for the tests and provides any configuration information required to set up the NMOS controller under test. So today we're not using DNS-SD to discover the mock registry automatically. We can do that, but we're not doing that today. So instead we supply the IP of the registry directly to the NMOS controller under test. So I just need to cut and paste that across into the NMOS controller. So because we're not doing DNS-SD testing, we will skip test 1, and when we hit next, it will take us straight to test 2 in the test suite. So test 2 ensures the controller under test can access the ISO4 query API of the mock registry. We can see on the NMOS controller that it's successfully browsed the registry. So once we've kind of exercised that API, we can click next and move to the next test. Test 3 ensures the NMOS controller can discover all the senders in the registry. We can see on the controller the senders that have been discovered. So you can see Mason, Gilmore, Barrett, and Wright. And we simply need to go on our testing facade and check the ones that we see, and then hit submit. Test 4 ensures the NMOS controller can discover all the receivers in the registry. Again, we note the receivers. We've got Idle, Gilliam, and Cleese that are available on the controller, and then we just need to check the correct ones in the testing facade UI and hit submit. Test 5 puts a sender offline and then takes it back online again. So as soon as we click the next button, one of the senders is going to be taken offline. So there we go. And we just have to select from the testing facade which of the senders went offline. And the second part of the test is waiting for that sender to come back online. So the testing framework will wait a random amount of time, up to 1 minute, before the sender comes back. If you click the next button before the sender comes back online, you'll fail the test. Also, if you click the next button more than 30 seconds after the sender comes back online, you'll also fail the test. So we just have to wait for that sender to reactivate, and we can click next, move on to the next test. So test 6 is identifying which receivers are controllable by the ISO5 API, for instance, allowing us to make connections between senders and receivers. So 4 new receivers have been put online. Only some of them have the ISO5 API, and in Sony's Live System Manager, only those receivers with the ISO5 API are displayed in the UI. So the receivers Bern, France, Weymouth, and Harrison have all been put online, but and what we need to do is actually see which of those have appeared in the interface. So we see, in addition to Idle, Gilliam, and Cleese that we had before, only Bern out of those 4 has actually appeared. So that is the only receiver that has an ISO4 interface. We select that and we click next. Okay, moving on to test 7. This ensures we can instruct a receiver to subscribe to a sender's flow using ISO 5. So the testing facade instructs which sender and receiver it wants us to create a connection between. So you can see it wants us to create a connection between the sender right and the receiver Gilliam. So on our NMOS controller, we make that happen. Click next onto the next test. Test 8 ensures we can disconnect a receiver from a connected flow. So the testing facade indicates the sender and receiver between which it would like us to remove the connection. We do that on our NMOS controller and click next, and we're on to the next test. So test 9 ensures that the state of connections on the network is shown correctly on the NMOS controller. So these connections will be made by the NMOS testing tool in the background, and the NMOS controller needs to display that status. So first off, we need to identify the receiver that's just been connected in the background. So you can see that's Cleese. So we need to go to the testing facade, select the correct receiver and click submit. So next we need to be able to identify the sender. So that's Mason, and we need to go and select that on the testing facade and click submit. So next, the connection will be deactivated at a random point in time. This is very similar to the sender going off and online, that it will happen at a random point. If we click too early or too late, we fail the test. On the Sony Live System Manager, we'll see a little icon appear in the corner when it deactivates. There we go. So we click next, and that's all the tests. So we have a post-test message to say you've completed the tests. When we click that, it completes the test suite, and we can go and inspect the results within the NMOS testing tool. So we can see here that test 1, was disabled because that's the DNSSD one that we weren't testing, but all the rest that we executed have passed. Okay, I'll pass you back to Rob.
Great, thank you, Jonathan. Just share again. So the semi-automated approach is great for testing involving a human operator, and we hope it will prove useful at future JTNM tested events. But for the purpose of integrating testing within the software development cycle, we thought it would also be really useful to have a fully automated way of running the tests. So in this case, the human operator and semi-automated testing facade are replaced with a fully automated testing facade incorporating a robot framework to drive the controller. So when the facade receives an instruction from the NMOS testing tool using exactly the same Q&A protocol as before, instead of giving instructions to a human, it carries out the instructions itself. And we use Selenium to do this. So this is able to drive the controller UI and collect information from the UI to send back to the testing tool. So again, a demonstration is the best way to show this. So Jonathan will now show this in action, this time using Sony's NMOS.js open source NMOS controller. So over to you again, Jonathan.
Thanks, Rob. Okay, let me find the right window and share that. Okay, so as Rob says, this will demonstrate the fully automated testing of Sony's NMOS.js client using an automated test facade that uses Selenium to drive the client's user interface. So similar to the semi-automated case, we obviously need to run up the NMOS testing tool. So we can do that. We can browse to the testing tool, select the NMOS controller test suite as we had done before, and configure it, this time with the IP and port of the fully automated testing facade. So we can then launch the fully automated testing facade, which is another Python application that launches its own browser that will browse to the NMOS.js client. So on the NMOS testing tool, we can select all tests and hit the run button, and then we're away. So on the screen, you'll see an indication of which test is underway at any given time. And obviously being fully automated, the testing facade requires no user input and can quickly run through all the tests in the test suite. This fully automated testing facade has been written specifically for NMOS JS in Python using Selenium. Details of the API between the testing tool and the testing facade will be given as part of the NMOS controller documentation. So this will allow vendors to write their own automated test facades for their own NMOS controllers. This example, NMOS JS testing facade, will also be made available as part of the NMOS JS open source project on GitHub. So once the tests are complete, we can then see the results of the tests in the NMOS testing tool. And we can see, again, we weren't using DNSSD this time, so that test had been disabled. But for all the other tests, we have passes. Okay, back to you, Rob.
Thanks again, Jonathan. So just back to the slides. So you can imagine how fully automated testing such as this could be incorporated into a vendor's software development process to ensure that any new code changes do not break the existing functionality. So where do we go next with all of this? Well, we'd really like more controller test suites to go beyond the fairly minimal ISO 4 and ISO 5 functionality that they currently cover. So for example, we could have additional test suites for BCP 00201 grouping, ISO 7 event and tally, ISO 8 audio channel mapping, and many more of the NMOS specifications, including the suite of security specifications. And to make this easier, we felt it would be really useful to have some dedicated documentation explaining exactly what's expected of an NMOS controller for each of these specifications. So we will hopefully be kicking off a new NMOS controller specification activity within the AMWA very soon. Please let us know if you'd like to get involved with that. We're particularly keen to hear what users expect from their NMOS controllers. So if you are an end user, it'd be particularly great to have you involved, but it's open to all AMWA members. If you're not an AMWA member and wish to get involved, it's a great reason to join the AMWA. So just to briefly summarize, AMWA's NMOS client testing activity added controller testing functionality to the NMOS testing tool. This will be publicly available very soon once our pull request on AMWA TV's GitHub has been reviewed and approved. It allows vendors, users, and systems integrators to test NMOS controllers themselves and confirm compliance with the AMWA ISO 4 and ISO 5 specifications. It should hopefully prove very useful at future JT&M tested events. And we've created an example of fully automated testing, and we think this is a good way to integrate testing into software development processes. And as I just mentioned, the next steps are to create a clear NMOS controller specification and use it as the basis for future controller test suites. So it just remains for me to thank you all for listening. Special thanks to Jonathan and Heather at Sony, who led and carried out all the technical work on this activity. Thank you.
So you did all this between May and September?
Yeah.
Wow, busy summer.
Busy summer for Jonathan in particular, yeah.
That's quite a piece of work. So you asked for other automated tests for some of the other NMOS specifications. Do you see those being developed, by individual organizations or companies and contributed to a common pool? Do you see those as being collaborative efforts? How do you see those things moving forward?
Yeah, so I think now that we've got the test framework in place and that's all going to be available on GitHub soon, it will be much easier for others to contribute tests to that. So there could be either some small AMWA activities that spin up just to create a certain test suite, or if people feel that tests should be added and want to do a pull request into the repository, just as they do with the existing NMOS testing tool, that's also an absolutely valid thing to do. And there's various people at the AMWA who'll be assigned to review and approve those pull requests, just as our NMOS controller testing pull request is being reviewed at the moment. So yeah, it could take either approach. So we're hoping, those who were involved in authoring some of those other specs will get involved in adding controller test suite functionality for those, just as they did create node and registry functionality for those specs back when the specs were developed.
Mm-hmm. So if somebody wants to get involved, how do they do that? Do they reach out to you, Rob, or is there another good way to identify for people to identify themselves as being interested?
Yeah, I think they can reach out to me. They can talk on the AMWA Slack channels or AMWA Basecamp. Could also ping Pete Brightwell, who looks after the AMWA incubator and is always interested in people spinning up new activities. But yeah, if it particularly relates to the client testing or especially this new controller specification activity that we're spinning up within the next couple of weeks, hopefully, certainly drop me a message. That would be great.